Crystal. Solids consist of atoms or molecules executing thermal motion about an equilibrium position fixed at a point in space. Solids can take the form of crystalline, polycrystalline, or amorphous materials. Solids, at a given temperature, pressure, and volume, have stronger bonds between molecules and atoms than liquids. Solids require more energy to break the bonds. Types of solids: single crystal, polycrystalline, and amorphous are the three general types of solids. Each type is characterized by the size of ordered region within the material. An ordered region is a spatial volume in which atoms or molecules have a regular geometric arrangement or periodicity. Crystalline solid. Crystalline solid is the solid form of a substance in which the atoms or molecules are arranged in a definite, repeating pattern in 3 dimensions. Single crystals, ideally have a high degree of order, or regular geometric periodicity, throughout the entire volume of the material. Single crystal has an atomic structure that repeats periodically across its whole volume. Even at infinite length scales, each atom is related to every other equivalent atom in the structure by translational symmetry. Polycrystalline solid. Polycrystal is a material made up of an aggregate of many small single crystals, also called crystallites or grains. Polycrystalline material have a high degree of order over many atomic or molecular dimensions. These ordered regions, or single crystal regions, vary in size and orientation WRT one another. These regions are called as grains, domain, and are separated from one another by grain boundaries. The atomic order can vary from one domain to the next. The grains are usually 100 nanometer, 100 microns in diameter. Polycrystals with grains that are less than 10 nanometer in diameter are called nanocrystalline. Amorphous solid. Amorphous, non-crystalline, solid is composed of randomly orientated atoms, ions, or molecules that do not form defined patterns or lattice structures. Amorphous materials have order only within a few atomic or molecular dimensions. Amorphous materials do not have any long-range order, but they have varying degrees of short-range order. Examples to amorphous materials include amorphous silicon, plastics, and glasses. Amorphous silicon can be used in solar cells and thin-film transistors. Departure from perfect crystal. Strictly speaking, one cannot prepare a perfect crystal. For example, even the surface of a crystal is a kind of imperfection because the periodicity is interrupted there. Another example concerns the thermal vibrations of the atoms around their equilibrium positions for any temperature T0 degrees K. As a third example, actual crystal always contains some foreign atoms, i.e., impurities. These impurities spoils the perfect crystal structure.